hopefully she'll just pop in. I did find her email, so I sent it to her. Perfect. So I'm really struggling with this, you guys. It doesn't help that I keep falling asleep during the readings and everything. I'm so tired. I'm so sorry.
Oh, good.
So,
let's do it.
Okay. I really appreciate you guys, just so you know. I'm so grateful.
Yeah. Okay, I'll read the first one. Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is H naught equals the mu D equals 0. The alternative hypothesis is it does not equal 0 and the population standard deviation is unknown. Jordan collects a sample size of n equals 9 and computes D bar equals 2.2 and SD equals 3.3. What is the value of the test statistic?
How do we figure that out?
Okay, so oh dear, hold on.
Wait, do we need those files right now for this one?
I don't think we need those files for this question yet.
Yeah, not yet. I have them all.
Okay. So an alternative is does not equal population. Standard deviation is not known. Jordan collects sample size of n equals 9 and computes D equals 2.2 and SD equals 3.3. So the equation is D bar, right?
Yeah, I'm trying to figure out what I do.
D bar, is it times T or minus T?
It's times T.
Is it times?
Oh, I don't know. What are you doing? I'm trying to figure out.
To figure out the margin of error.
Okay.
So if we're finding out the statistic, we need to figure out what T is.
Yeah. How do you figure out what T is? Is that from last lesson?
I think there is an equation for it. And
yeah, I just can't remember it.
I know, I'm out of town.
I remember that D bar is the same thing as X and SD is the same thing as sigma.
Well, I know to figure out the margin of error for the t-score, it's T times SD over the square root of the number. Right? But you have to know what T equals, don't we? Are we supposed to be using the Excel file for this question? I'm so confused on where to even start with this one.
No, there's an equation for the test statistic.
There's an equation for the test statistic.
And it's it's tiny. Oh, what is it? Hold on.
I don't know. I'm just gonna pull up the textbook again, read it real quick.
Okay. It wasn't in today's reading. I think it was from last week or the week before even.
Well, but I think it is in this one. Well, while I'm pulling this up, what do you guys want to do for a group project?
Yeah.
I haven't looked at what she put as ideas out. Do you guys have any ideas that you want to do?
I haven't looked at her ideas. I just remember he said no candy.
Yeah, no candy.
No candy,
no candy.
And no humans.
No candy, no humans.
That's right. Otherwise, we have to get it all approved by some department. We don't want to do that.
Yeah. I think it's
Oh, I found a t equals thing.
What is it?
Well, it's
Where are you
giving
at?
numbers, not an equation.
Oh, I feel like it's
I think it's the same
really
thing
similar
as the
to the
z-score.
z-score. Like,
Yeah, because what is the z-score? Z
I'm trying to
equals-
remember. I think it's the value minus the mean divided by like the standard deviation minus the square root of n or something like that. I just don't remember the order. You know what I'm talking
Okay,
about?
well, I have those things written down. So, like the z-score to figure out the, oh, what is it called? Oh my gosh, the margin of error, I'm sorry, is the z times sigma divided by the square root of 25, right?
Yeah, that's how you find the margin of error, but we're looking for the z-score. So Dennis is right. It's the z equals the value minus the mean over sigma divided by root n.
Oh, it's sigma divide. Okay, I was like, I couldn't remember if it was divided by or minus. Okay, divided by sigma. So the standard deviation divided by root n. Okay.
Yeah, so for the t-score, it'd be t equals, what would be in place of value here? Is it x bar minus mu? It doesn't make
It's
sense.
d bar minus,
So it'd be d bar minus mu?
yeah, so it'd be 2.2 minus 0 divided by
Divided by
3.3 divided by 3.
root 3 or 3? Just 3.
Well, it's root 9, which is 3.
Yeah. Do you know where we're coming up with this, Carrie?
Where are you finding this?
Okay, well, it's just from past lessons about like finding the test statistic.
Mm-hmm.
So we're just using like the equation we used like 2 or 3 weeks ago, where like the z equals x bar minus mu
So did you guys
over. Go ahead.
Sorry, did you guys get 2.2?
Yeah, so this one's going to be t equals 2.2 minus 0 over 3.3 divided by root 9.
Oh, divided by root 9. So I did. Okay, so let me do this.
Janessa, did
Okay,
you
so
get 2?
I still get 2.2, right? Or
For
am I
the
off
total
it?
answer?
Yeah.
I got 2.
I got 2.
Okay, so I'm probably just inputting it wrong in the calculator.
What's the equation you wrote down?
I wrote down t equals 2.2 minus 0 divided by 3.3 divided by the square root of 9.
Yeah, so that's the right equation. So,
Well, so I'm just wondering if I'm just put it in the calculator, I have to like
Yeah.
do equals.
That's probably why, because you can pretty well do this one in your head after you've got it written down. The root of 9 is 3, so 3.2.
Not me, because I'm not that good. But you are, so good job. Okay, I'm so doing it wrong. Okay, so 2.2 minus 0 is, of course, 2.2.
Yeah.
Okay, so I divide that 2.2, right, by 3.3?
Not quite. So you got to do 3.3 divided by 3 first.
So 1.1?
Yeah, on the
Then-
bottom. So it'd be 2.2 divided by 1.1.
Okay, so that's 2.
Yeah.
Okay, but what about the dividing
Yep.
it by the square? Do I still
So
divide that by this?
On the bottom is 3.3 divided by root 9, and root 9 is 3. So that's where it was 3.3 divided by 3.
Oh, okay, so it is 2.
Should be 2. If it's not 2, then we've got the entirely wrong equation.
Yeah.
I'm pretty sure we got it right.
Okay. Okay, so I'll read question 4. The probability of obtaining a test statistic greater than Jordan's test guys, I'm so sorry. Statistic is 0.0403. Usually this probability, okay, this probability determined the p-value for Jordan's hypothesis test. So how do we do that?
Good question.
Where's Justina? Just kidding.
I know, huh? I'm hoping she comes.
This is nothing like the homework, too.
I know, it's not, is it? It's like totally different. Well, once we get down a little bit, I think,
Probability of obtaining a test statistic greater than Jordan's test statistic. 0.0403. I'm guessing we might use the applet, but
okay, I have.
Oh yeah, I think this is where you've got to where you have like the big p-value and you minus it by the little p-value, so you've got like the other p-value. Does that make sense? Probably not.
Not to me. Sorry, over my head.
What's the degrees of freedom here? We've got 9n, so 8 is the degrees of freedom. Hello?
Hello? Sorry, my phone is ringing.
That's okay.
Hello, no one is available to take your call. Please leave a message after the tone.
So would we input the 0403 into the applet?
I think we go into the applet and then on the right-hand side, shade that. And for the t-score, put in what we just got, which was 2. And that gives us the p-value.
Is it 0697?
I got 0.0403. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis.
What's the degrees of freedom?
We put in the test statistic and the degrees of freedom and do like the shading, but I feel like that's not what it wants us to do, you know?
Yeah, well, it's definitely not because I got 0.0403.
When you did the shading?
Yeah.
I got 0.0805.
Did you shade only the right side?
No, I shaded both sides because
it is supposed
the alternative hypothesis does not equal.
So it's a two-tailed test.
Oh, I get what it's asking now. It's saying if it was shading just one side, then it would be 0.0403, but it's asking for does not equal to, so it's asking for both sides. So we basically just have to double that.
Oh,
so
yeah.
I think, you know what I'm saying?
Yeah.
So smart.
Okay, so
I'm so glad you guys understand each other. You're so good.
Okay, so Carrie, when you read the question, it says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. So what does that sound like, a one-tailed test or a two-tailed test to you?
It sounds like one because they're wanting to know greater than.
Right. If you read the question, so if you scroll up to like before question 3, it says that the alternative hypothesis is mu does not equal 0. So the question is really asking for both sides, and this is telling us what the one-tailed test side is of it. So we basically just have to double that score. Does that kind of make sense?
So then if we put that in the probabilities applet thing, the student probabilities, would we
Uh-huh.
put that number?
So so we don't even need to really use the applet. So
Oh,
we
okay.
want a two-tailed test, right?
Correct.
We want left and right-tailed. This is giving us the right tail. So to find both of them,
So then we
double
just
them.
multiply that by 2, right?
Yeah. Yep.
Okay. Oh, thank you. You're so good.
This was a weird question. And we have to round to 3 decimal places, so it's 0.081 is what I got.
Okay, so I got 0.0806. Okay, so let me redo that.
No, that's correct.
That's
But
right.
if
'cause
we have
that's
to
around
round
to 3.
3.
So 0.08. Okay, you have to round what?
To 3
It says
decimal.
round to 3 decimal places.
Oh, okay, so 81. Yeah.
Yeah.
A woman
You're good.
carried
You're good.
that. You guys
Okay,
are
there
so
we go.
awesome.
That was a weird question. I get it now, though.
Yeah, I didn't like
Awesome.
it.
Caleb, want to read the next one?
If anyone's in charge of these questions, you can make them a little more clear.
I know,
Um,
huh? You tell-
Yeah, use data file chapter 12 data A1.XLSX to answer the next 6 questions. Perform a paired samples t-test in SPSS. Be sure that the test does group 1 minus group 2. You'll use a null hypothesis of HO mu D equals 0. Alternative hypothesis of mu D does not equal 0. And the level of significance of alpha is 0.10. Wait, so do we have to do this in SPSS then?
No,
We can
I
just
think
do it.
So
we,
this is where
Oh, right?
Yeah, this is where we use
Excel,
Excel.
Yeah. Well, I don't know. Just because it
Group
says
1 minus group
perform
2.
samples test in SPSS, so I didn't know wanting to do that. Seems is not like the other.
I don't know if I did that right. Let's check.
So
So 21.
just to double check, everyone's in the quantitative inference procedures Excel sheet, yeah?
Yes.
Yes.
And then on the bottom, the tab paired sample t-test.
Yes. And we use make sure it's group 1 minus group 2 difference.
Wait, where does it say that?
In what you just read.
Well, I don't think we can change that on the Excel sheet. That's what I'm saying.
Okay, I got mine in there.
What?
Can you even change that on the Excel sheet?
The
What do you-
Excel sheet. You just have to do.
You don't want to change it. What all you want to do is just copy and paste it into your paired
Yeah.
sample t-test.
That's all I did, but then Janessa said make sure that it says number 1 minus number 2.
Well, they should have it in there already.
Yeah. I'm just asking if I'm supposed to watch out for changing it. That's all. Never mind. It's a dumb question. Let's keep going.
I'm sorry. Okay. All right. So what is the test statistic? Really, I can say it.
I got 0.407.
Yep, 0.407.
What is the p-value? I got 0.68877.
Yeah, but how many
435.
reasons?
So 0.689.
Yeah. Okay, so what is the correct decision to base on this evidence?
He is high. Keep the
Fail to
guy.
reject.
What?
He is high. Keep the guy.
Fail to reject. Yeah, keep the guy.
So we're going to fail to reject the null hypothesis.
Uh-huh.
All right. Suppose your alternative hypothesis is instead mu d is greater than 0. What is the correct decision based on this evidence?
So
P-value then changes to 0.344. So we'd still fail to reject.
so then we have
I
sufficient
say
evidence.
B, we have insufficient evidence that the mean of the differences is greater than 0.
Yeah.
Or wait. Is that right?
Yeah.
Yeah.
Because we keep the guy.
Mm-hmm.
Okay.
Okay. Next one.
All right. We good for number 9?
Sorry. I'm almost
Wait. Like, can I read it?
there.
Jeez.
Yeah.
Yeah.
Use that data file to answer the next 8 questions. Perform a paired sample t-test in that. Be sure the test group is 1 minus 2. This data comes from another Excel sheet. The null hypothesis is null hypothesis mu d is 0. Alternative hypothesis is mu d is not does not equal 0, and the level of significance is 0.01, which is greater n or df.
N.
And
And yeah, I don't even have to put the Excel sheet.
it's always going to be N, right?
Yeah, because to get df, it's n minus 1.
Yeah. What is the p-value?
Basically, 0.0.
I have 0.00121. So 0.001.
Yeah, it's not equal to, right?
So yeah, it's 0.001.
Yeah, 0.001.
Okay, well, it's smaller than.
So we reject the null?
Yes.
Yeah. Use low, reject the hoe.
It sounded like you said something different. I won't repeat it. Sorry. Okay.
Okay, you decide to try another alternative hypothesis. This time you use alternative is greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? Decrease, right?
Okay, that's a trick question, because if you change it to greater to, technically, or greater than, technically it decreases, but using their rounding, it's still going to be 0.001.
But stay the same isn't an option, so I'm just going to say decrease.
Yeah. You're tricksy.
But I understand. Yeah. What decision did you make? Reject.
Reject that. Reject that stuff.
It's out of here.
Based on your response from the previous question, which conclusion do you make? It's going to be sufficient evidence.
Yeah, do you think it would be A?
What's the The
Mine's
null.
really small.
I think it would be C. Would it be C?
Our null, we're saying that it is 0. So we should be saying that we have sufficient evidence to say that there is a difference. Yeah.
That there is a difference?
We
Yeah.
have sufficient evidence that there is a mean difference between the two groups.
Okay. All right, Carrie, you want to read 15?
I do. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Is it mu is not equal to 0? The mu difference is less than 0. Not enough information depends on the problem, and mu is greater than 0. So what's going to give us the smallest p-value?
Greater than. So that's D. Yeah.
Yeah, I agree.
Alligators can eat it.
Is it D or is it B?
Or is it what?
Why is it D?
Because that's greater than.
Why is greater than smaller than less than?
Because generally speaking, our thing isn't going to be over on the left side of the bell curve. So the right side of the bell curve will generally be smaller. Or we can say, I guess we could say not enough information depends on the problem.
I think it's one of those, not necessarily a trick question, but something where, we need to know. I don't even know how to explain myself, guys. I don't know how to spit it out.
Well, statistically, half of our stuff is going to be on the left and the other half is going to be on the right. So it should be not enough information. Depends on the problem.
Yeah, that's what I don't understand.
So if our mu difference
What do
is
you-
greater than 0, then that would that make our p-value the smallest? I think it would, because if you think about it, if it's over on the left side and the left side is greater, that would give us a smaller p-value. Is that too simple of an answer? Is it more complicated than that?
I'm going to say not enough information, and then if we get that wrong, we'll go back and do greater than.
Okay,
Okay.
I'll do the greater than.
Okay. Determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2. Input your answers below.
Okay, so that's already done here, right? So that's at 95.
This is for the same information, right?
I believe so,
Yeah.
yeah, because we're supposed to. So
What was it? 5.0.
5.303 and then 18.607.
Yeah, do we just put 5.303 comes 18.607? Like, what's going on here?
Okay, what is the point estimate?
Wait, what is the point estimate?
Yeah, what's the point estimate? Let's look. Does it have it?
What is the point estimate?
I think the point estimate is the middle of, like, oh gosh, sorry, I'm getting tired. Okay, so if the confidence interval was 4 and 8, I think the point thing would be 6 because that's the midway point between them, right?
Oh,
I'm
Okay.
confused. What are you looking at?
I just made up numbers to make it easier.
Oh.
So like if our confidence interval was 4 and 8, the margin of error would be 2, and in between so 2 above 4 is 6 and 2 below 8 is 6. So 6 would be
Okay.
the
so
point
you just wanna
estimate.
find- At the mean between the two confidence intervals, right?
Can we just find the mean?
We can by doing the x and subtract them and then divide them by 2, right?
Yeah, we'll add them and then divide them by 2.
No, you're supposed to subtract, I believe, isn't it? Let me see.
Well, if you're going to find a mean, you need to add them. You can subtract them and divide by 2 to find the margin of error.
Oh, I'm thinking of the other thing. Okay.
The margin of error? Yeah, let's do that because that would be.
Well, yeah, isn't the margin, because that's what we're finding really is the margin of error. Isn't that when you subtract? For some reason, I feel like we need to subtract.
Yes, we can do 18.607 minus 5.303 gives us 13.04. We divide that by 2 and gives us 6.652. So that would be the margin of error.
6.65.
I get that. Okay.
Yeah.
Which is number 17. So you can put that in for number 17. But
Then
then
you
for number
would-
16, just add the margin of error to 5.303.
So 11.955.
I don't know, my calculator did something weird and I got 2, and I know that's wrong because I hit plus.
So for 16, we need to add the 5.
Yeah, so for 16, add, what is it? 5.303 to 6.652. So we're adding the lower confidence interval to the margin of error to find the middle point. And I got 11.955.
That's what I got.
Yeah, 11.955. And that's for number 16, right?
Yeah,
Yeah, 17's the margin of error, which we already did is 6.652.
So input the lower bound. Okay, so
5.303.
yeah.
Upper bound 18.607.
yeah.
Hmm.
Yeah, Carrie, real quick before you submit it on question 15, it is not enough information, depends on the problem.
It is okay.
Yeah. That's right.
Thank you. I appreciate that.
Yeah.
Because I'm already going to be missing one because I didn't get this stuff done before we met because I was just so confused.
You got that one wrong, Caleb?
I got it right when I put it into not enough. Information depends on the problem. I mean, I didn't miss anything.
Did
Did
you?
you miss something?
The one that says never mind. Like not enough information. Did you get that one right?
Yeah.
Yeah.
So you got them all right then?
Yeah. Did you guys miss one?
No, I haven't submitted.
And you
that
put
yet.
not enough information?
Yeah.
Okay.
Okay. Yep.
Did we all get it?
Yep. Mine are all right, except I had to put. I didn't finish the preparation assignment, so I don't have 100. But
No worries. Nessa?
Sorry, my computer's being super slow. I had to reload it. But it saved all my answers.
oh, good.
Are you in the office?
No.
That's probably why.
Yes, submit. Yay.
Yay!
Awesome.
Cool. So I'm not going to be on Thursday because I'm going to be rock climbing.
What? Hello?
Yeah.
That'll be fun. Well, good for you.
Yeah. So it might just be you guys. Hopefully, Justina. I don't know.
I know. Huh? All right, guys. Well, good to see you, and thank you for your help again. I'm gonna get a hold of Justina and see about her tutoring me or something. Is that what we're supposed to do? Is she supposed to help us that way, or do we contact them?
Yeah, I think she has like specific office hours, so you could ask her about that.
Okay, perfect. Well, have fun rock climbing and be safe. Okay.
Yeah, I will.
Okay. We'll see you later. Bye, Janessa. Have fun.
Thanks, guys. See ya.
Bye.
Bye bye.